In March 1999, the world's first two-vessel rocket launcher is ready to embark on its maiden mission. The builders of Commander and Odyssey have leapt complex technological hurdles in record time. Now, it's time to test this megastructure's mettle. After an 11-day expedition from their home port in Long Beach, California, Commander and Odyssey reach their destination at the equator. As the Odyssey straddles the equator, the dynamic positioning system is holding it steady at 0 degrees latitude, 154 degrees west longitude. This all-important debut launch will feature a satellite called DemoSat. This payload mimics the size and weight of a real satellite. The major difference, it doesn't have an anxious paying client attached to it. At 3 hours before launch time, with all systems in place, every member of the launch pad crew evacuates Odyssey across a steel gangplank extended from Commander. With Odyssey's crew safely aboard, Commander puts 5 kilometers between itself and the launch pad. On the abandoned Odyssey, the Virgin launch is now in the hands of an automated system. Fuel flows into the rocket from huge pipes at the bottom of the launch pad. Once fully fueled, the rocket will weigh nearly 500,000 kilograms. The transporter erector tucks itself back into the hangar. Hangar doors close, protecting the valuable equipment inside from the rocket's blast. 5 years of incredibly hard work is about to reach a fiery climax. DemoSat is lifted from its ocean-going launch pad on the equator to geosynchronous orbit 35,900 kilometers straight up. The first launch is a success.
You know, the whole business is at stake on a launch. And to see it lift off and to see it go through the operation is just an incredible defining moment.
Seven months later, in October 1999, Sealaunch follows this perfect test launch with its first official launch. The 3,400-kilogram direct-TV satellite becomes the first commercial satellite launched from sea. The concept is proved. The technology works. In March of 2000, the company launches a $100 million communication satellite for a London-based company. It's a picture-perfect launch. Then, 8 minutes into the flight, radio contact is lost, and the rocket plunges into the Pacific. After 2 months of exhaustive investigation, the failure is tracked to a software problem. The automatic system didn't close a fuel valve on the second stage rocket. The second stage engine shut down too early, and the launch self-destructed. By the end of July 2000, Commander and Odyssey are back at sea, hurling another rocket into space. 1 hour and 37 minutes after liftoff, Pan Am Satellite 9 is in geosynchronous orbit above the Earth. In October of 2000, there's another milestone. Sealaunch breaks the world record for heaviest commercial payload, when it effortlessly tosses a 5,100 kilogram communication satellite into orbit. This mega-heavy launch proves that the Sealaunch equation works. In the next 4 years, Sealaunch successfully puts 8 more commercial satellites into geosynchronous orbit above the Earth. A dazzling string of achievements for this seafaring launch pad. But as the Sealaunch team revels in their success, the odds catch up with them once again in June of 2004. The Telstar 18 satellite launch experiences a malfunction. The third stage rocket delivers the satellite to a lower altitude than expected. Then, in December of 2004, the launch of Intelsat America's 8 was called off, cancelled at the 11th hour by the client because of potential problems with the satellite. These back-to-back mishaps put enormous pressure on the first launch of 2005, Mission 15. If this launch is a failure, the entire operation could be at risk. As with every liftoff, 6 underwater valves are opened in the pontoons, and Odyssey's legs take on thousands of litres of water. The platform sinks to a depth of approximately 22 meters, making it stable for launch. A dynamic positioning system acts like an anchor, holding the platform in place. The rocket emerges from its hangar, and the hydraulic arms of the transporter erector push it into ready position. If this countdown doesn't end in a launch, both vessels will have to return to port with Mission 15 still incomplete. 3 troubled missions in a row would be a devastating blow. Tension is in the air as the crew watches the rocket prepare and the screens flash. What looks like steam coming from the rocket is actually liquid oxygen discharge, a normal byproduct of fueling. Clocks keep count until the last 10 seconds.
10, 9.
The count from 10 is the only countdown in the world done in both English and Russian.
Main engine start coming. 2, 1. Lift off. Main engine is at nominal flag.
Mission 15 liftoff is a success. As the rocket disappears from view, the most crucial elements of this launch are yet to come. They take place kilometers above the Earth. It will be an hour before the crew in the command center will know whether Mission 15 is successful. 2 minutes into the flight, about 70 kilometers above the Earth's surface, a spent Stage 1 successfully separates from the Ukrainian Zenit rocket and falls to the ocean. The engines on Stage 2 begin to burn, and the rocket slows down to a mere 9,600 kilometers per hour. A minute later, the fairing protecting the satellite at the tip of the rocket also falls away. Stage 2 burns for 6 minutes, then it too falls away. Now it's up to the Russian third stage, called the Block DM, to complete the satellite's journey. The rocket is now 180 kilometers up and 6,400 kilometers downrange. The third stage fires up for 2 longer burns and pushes the satellite from suborbital into orbital space above the Earth's surface. 1 hour after liftoff, the third stage separates. The satellite is on its own. Within minutes, a station in Africa reports receiving a test signal from the satellite. Mission 15 is a complete success.